Hello, we're going to look in this video at some of the ways that linear relations can be applied to situations. And once we can write a linear equation that can represent a situation, we're able to do all kinds of things with it. We'll look at that later, but for now we're just going to look at how we can write an equation of a line that represents some types of situations. So let's look here at this example where Armand has $35 to spend. Cookies cost $3 each and eclairs cost $4 each. So we want to write an equation representing how many of each he could buy. So the first thing to recognize here is that we have two unknowns. We have the number of cookies and we have the number of eclairs. And we want variables to represent each of these. Now I can use X and Y, but I'm going to use letters that sort of represent each thing. But I do need to define them, even if it seems sort of obvious. So let's C equal, and now C doesn't equal cookies. I want to be very precise here. C equals the number of cookies that he buys. So the number of cookies. And then I'm going to use E to represent the number of eclairs. So shorthand here, the number of eclairs. So now what I have is a situation in which I've defined my variables where they represent the number of cookies that he's buying, the number of eclairs that he's buying. So then the overall equation can be represented by, well, the cost of the cookies, $3 each, times the number of cookies that he buys is how much money he spends on cookies. If he bought 6 cookies, then 3 times 6 would be $18 spent on cookies. Eclairs can be represented by 4E. So 4E is representing total how much money he spends on eclairs. $4 each times the number of eclairs. So if he buys, say, 7 eclairs, 4 times 7 would be $28 spent on eclairs. Since his money is additive, whatever money he spends on cookies plus whatever money he spends on eclairs, now I'm going to write this as an equation, equals 35. Technically, I should probably do this as an inequality. It's less than or equal to 35. He doesn't have to actually spend all of his money. But if he did want to spend every single dollar he has, then the possible scenarios, the possible, solutions to this would have to be solutions to 3C plus 4E equals 35. Now, if I were to consider graphically what that looks like, I can define, let's say this is the C axis and this is the E axis. I can represent this on a graph by figuring out, first off, if he bought all cookies, so just cookies, 0 eclairs, this would be the horizontal axis, then 35 divided by 3 would be 11.66666. Now, obviously, that's not a possible solution, but I'm going to put 11 and 2/3 would be kind of here. And if you bought all eclairs, so 0 cookies, 35 divided by 4 would be 8.75. So those are the two intersections with the axes. And if I connect them, any point on this line is a solution, a possible solution. Now, it's a little more complicated than that. If this were on a grid, I could obviously only use grid points. They would have to actually be whole numbers because chances are good the bakery's not going to let him buy 3/4 of a cookie. But this line, now notice I haven't extended it into the negatives because he also can't buy negative numbers of eclairs or cookies. But any whole number points that exist on this line would be possible solutions to this situation. Another possibility that we have here, let's say we have a printer. So to print copies of a booklet, the printer is charging $2 per copy with a set startup fee of $19. So whether they print 10 copies or 100 copies, they're going to cost $19 to set up and then $2 per copy. We want to write an equation that represents the total cost of printing N booklets. So N has already been defined for us here. N is the number of booklets, but we need to define a second variable. We're trying to represent the total cost. So I'm going to let C equal the total cost. We want an equation that represents the total cost of printing N booklets. So I asked myself, how would I calculate the cost for a known number of booklets? So if, for example, I were printing 1 copy, then it would cost me $19 plus 2 times 1, so plus 2. If I were printing, so let's say we have N and C, just to kind of look at a relationship here. If I were printing 1 copy, it would cost me $21. That's 19 plus 2. If I were printing 2 copies, it would cost me $23 because it's the original 19 plus 4 because now I'm printing 2 copies at 2 each. If I were printing 10 copies, well, that's going to be the 19 startup, but this time plus $20 because $2 for each of the 10 copies, so $39. This process gives me a hint as to what my equation should be because all of these, to calculate the total cost, start with 19. But then this other number, the 2 or the 4 or the 20, that's the $2 times the number of copies that I buy, so 2n. So this is an equation that represents the total cost of printing n booklets. So now if I knew I wanted to print 100 booklets, for example, I could replace the n with 100. 2 times 100 is 200 plus 19. So that is an equation that represents the total cost of printing n booklets. Again, it's a situation in which n would definitely have to be a whole number. The printer is not going to print 8/10 of a booklet for you. But within that restriction, this equation will then allow me to figure out the total cost.